Hi everybody, and welcome back for another Simple Science. So this is the last Simple Science of the summer. We will be taking a short 2-week break of all of our virtual content and programs to go, so we can take a little bit of a break and also get ready for what we're going to be bringing you in the fall. So keep an eye on our calendar for more details on that coming up. There's still time to sign up for summer reading. We have some the prizes are in, and you'll be able to pick those up shortly. You'll also be eligible for our grand prize drawing that we'll be having in just a few weeks. All right, so today's experiment is called Drops on a Penny, and we are going to be playing with surface tension. So for what you need for this experiment is you're going to need some water, a dropper, like an eyedropper. If you don't have an eyedropper like this fine, like a little medicine one will do if you wash it and clean it really well. And then if you don't have one of these, you can also dip a Q-tip and just kind of squeeze it to get little drops out. You are going to need a penny, and you're gonna need some paper towels just to put the penny on. All right, so what is surface tension? That's what we're gonna be experimenting with today. So surface tension is a property of water or a property of liquids that tells you how sticky the surface of it is. So we played with the surface tension a little bit before in one of our previous experiments, the milk rainbow, where when we dropped the food coloring on, the food coloring stayed put because the surface tension was really tight. But when we changed the surface tension by adding soap, then the colors were able to swirl all over the surface of the milk. So what we're going to be doing in this experiment is we're going to be dropping the water slowly onto the penny, and you'll see that the surface tension is going to keep the water in a sphere. So you can drop several drops onto the penny and it won't just splat all over the place. It's going to hold it all tight, and it's going to hold it into a little droplet, and you'll be able to see it. And we're going to see how many we're going to count. We're going to get a close-up and we're going to count how many drops we can fit on the penny before the surface tension breaks. When the surface tension breaks, the water will go everywhere. You can also play with surface tension with bubbles, which is why bubbles are always round after they come out of the bubble wand, no matter what shape your bubble wand is. And you'll be able to play with more experiments about that with this week's program to go, Bibbidi Bobbidi Bubble. All right, now let's take a closer look so we can count how many drops we can fit on this penny. Okay, so we're all set up for our super close-up shot. So what I'm going to do is I'm going to suck up some water into the dropper, and I'm just going to come over here and just start dropping drops onto the penny. So 1, and you can see there's a little teeny tiny little sphere on top of the penny. 2, 3, 4, 5, 6, 7, 8, 9, 10. So at 10 drops, we can really start to see that there's a bubble forming on top of this penny. Now, when you're dropping the water onto it, you don't want to be just squirting it on there, because the force of the squirting it on there is going to break the surface tension. So you do need to be a little bit careful when you're dropping this on. All right, so we're going to keep going. So we're at 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So now we're at 20 drops. Still see the awesome sphere, like half sphere shape. Just wanting to form a little bubble. It's almost getting to the edges of the penny. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, so it's 30 drops. The penny is almost completely covered, and we're still able to keep going. All right, let's see how many more drops we can fit on here. 31, 32, 33, 34, 35. Okay, there's 35 drops. A cool way to add to this experiment would be to not only try with a penny, but you can try with a dime and a quarter and a nickel, and see how many drops you can fit on that change as well. Okay, so we're at 35, 36, 37, 38, 39, 40. Okay, we're a big old 40. And you can see that the bubble's starting to look really puffy around the edges of the penny. So it's hanging over almost the edges a little bit. And so I'm sure that the surface tension is really straining to keep that water on top of the penny. $36, $37, $38, $39, $40. Ooh, there's 40 drops. All right, let's keep going. Starting to look like a muffin. 41, 42, 43, 44, 45. All right, so this is so cool. So now you can actually see where the edges of the water are starting to hang out over the sides of the penny. Who would have thought you could do that? But that surface tension's pretty strong. It's keeping all that water in place. All right, so we're at 45 and then 46. Oh, there we go. And the surface tension broke. So this is the drops on a penny experiment. And you can see we got up to 45 drops of water on top of this penny before the surface tension broke, and the force of the water had to push through that surface tension to make it spill onto the paper towels. All right, and there you have it. Who knew we could fit so many drops of water onto this penny? We hope you've enjoyed all of the content we've been able to offer you this summer. We will be taking a short break, and we'll bring you back more excellent content like this and more programs to go in the fall. All right, see you in a few weeks.